Hi guys, Mr. T again. Glad to have you back with us today. We're going to talk about complex numbers here. Numbers are complex enough, you thought already, but no, what we're talking about here is what is a complex number and how can you add, subtract, and multiply complex numbers? You already know how to do most of it already. Just got to add a couple little things to it. Don't get put off by this, the term complex number. It's not that going to be that big a deal. Okay, so let's just look at some real simple stuff right off the bat. So the first thing to do, we're going to do some exploring with some old ideas. And so we have here, we got this 3 plus 4x and 2 minus x. Okay, and we're just going to add those. Okay, we're going to add these binomials first thing. Okay, and so we see here, and they got this set up. So what they did is say, let's rearrange this according to our like terms. Okay, all right, well, that's fine. That's one way to do it. So they said 3 and 2, so that's going to be 3 plus 2 there. Put 2 there. And then they put the 4x plus negative x, so that's going to be negative x sitting right there. Okay. And so they just kind of reorganize that. So 3 plus 2, that makes 5. And then plus 4x minus x makes 3x. Easy as can be, right? No big deal. Okay. Now let's say let's subtract those. Okay. So what's this going to do to us? Okay, we need to distribute the negative. So this is going to turn over here to negative 2, and then instead of minus negative x, so it's going to be plus x. That's how that do that. Okay, now we have distributed the negative sign, so the subtraction. This is the worst thing about complex numbers almost, is people being able to distribute the negative for the addition and subtraction. It's one of the hardest things about it, which has nothing to do with complex. It just has to do with old stuff that we're supposed to know already, and human error. So here we go. Let's put our common like terms together here since it's all addition. So it's not FOIL. That's an addition sign. There's no multiplication here. So 3 plus negative 2. So there's negative 2. Then they're saying our other like terms are 4x plus positive x. Okay. And so that gives us 1. And then 4x plus x makes it 5x. So hardest thing about that is making sure we distribute the negative sign. All right. Easy enough. Now, we talked about this, is this concept of I. What is I anyway? Well, we said sometimes we end up getting a square root of a negative number, right? And so anytime we see square root of negative 1, we're going to call that I for imaginary number, and that's just its definition. So what if this problem didn't have x's and it had an I in its set instead? Well, let's just look how that would be. So if we put an I here, an I there, an I here, an I here, an I there, there would be 0 big O egg, 0 difference when it comes to adding, subtracting with I. None. It's kind of like pi. When you have pi, the symbol pi plus pi is 2 pi. Pi times pi is pi squared. So it acts just like a variable, but it happens to be a variable that you know what the answer is, okay, what the number is. So if I was there, there'd be 0. How much? 0 difference, right? All right. So easy enough. Adding complex numbers, no troubles. We can make that happen because this is what a complex number would end up looking like. Okay, it's just got 2 pieces to our answer. All right. So what about this? How about subtraction? Would that be different? Well, see if there's an I here, or an I there, or an I there, and an I there, and these were I's. Would that change things? Not a lick. Everything would work just like it did before. No changes. So with addition, how many changes? 0. With subtraction, how many changes? 0. The hardest part about subtraction is distributing your negative and rewriting that and not being too lazy to rewrite it. Please rewrite it. Okay, this step here of rewriting is the key to most people getting this right. Has nothing to do with the I. has to do with having to deal with that negative sign appropriately. Okay, and so that's all back new, like pre-algebra stuff. Okay, so adding, subtracting with I or complex numbers, no big deal, easy peasy, no big deal. All right, so let's check out multiplication. Okay, so let's run down here to our next slide and check out multiplication. So let's review. Oh, this is that FOIL thing, right? And so 3 times 2, that's our F, there's 6. 3 times negative x, that's negative 3x. Okay, so we distributed our 3 to both of those. Now we're going to distribute the 4x to both of these, and that's going to be the I and L. So 4x times 2, that's 8x. And then 4x times negative x, it's going to give me negative 4x squared. Okay, these two guys are like terms, right? So that's going to give us 5x and then plus a negative 4x squared. No big deal, right? No big deal. Okay. So is this going to be, so if what would happen if that was an I instead of an X? Well, let's look at this. Okay. So that if we put an I here and then we put an I there, would that change anything? So let's think about that. I and I. No, it wouldn't change that. When you multiplied it out, still be I there. That'd still be an I squared. That'd still be I there when you combine the like terms, and that'd still be I squared here. So no changes, just like addition and subtraction. Hold on just a second. There is a little something going on here. So let's look at this. So we said that I is equal to the square root of negative 1, right? So if we take I, which is the square root of negative 1, and we square it, it means what we do to one side, we do to the other side, right? So if we square it, what happens when you have a square root and a square? What happens to those guys? They end up canceling each other out, and whatever's inside plops on out to the next line. I say like a brand new cow. You don't worry about what it does and what cleaning it up or anything like that. You just got to get it out first. So here's our negative 1. Okay, so what we've discovered here is that if I equals the square root of negative 1, I squared must equal negative 1. And guys, I'm going to beg you, don't memorize that, okay, on purpose. Hopefully you will memorize it, but not just memorize it on purpose. What I don't want you to do is say I equals negative 1, put this in this box over here, and then I squared equals negative 1 and put that in this box over here. Don't want you to doing that. Okay, what I want you to do is I want you to memorize the definition with I squared root of negative 1. And then think, a square root squared, what would happen? Oh, that would just give me plain negative 1. I want you to remember the logic that gives you the negative 1. After you have used it several times, yes, you're going to memorize it. But what I want you to do is I want you to hook into, here's one thing, and then that logic brings you to the other thing, okay? Not this box and this box separately. I want you to think, here's this definition. And if I square it, what will happen? It will give me negative 1. Okay, so hook it to the logic, and you're more likely to remember those things. And yes, you're going to memorize it, but it's going to be from use and repetition, not because you just stuck it in there and tried to remember it. Like, oh, try to remember, like you memorize spelling tests and things like that, and that kind of deal. Don't do that. So, okay, but because we do know this information, what difference is that going to make? Was that going to change my 6? No. Is it going to change my 5i? No. Is it going to change my negative 4i squared? Yes, it is. So we're going to have negative 4. And then what does I squared equal? Well, we said that I squared is the same thing as negative 1. So make sure you write this step, okay? And then what's that going to give me? Well, 6 plus 5i plus 4. Okay? And then we notice something here. We got some like terms, don't we? So now we're just going to combine like terms, just what comes natural, isn't it? And then we call this 10 plus 5i. Okay? And that would be the answer. So our question here was, is there any difference with FOIL that when you have just a regular variable like x than when you use I? And for the most part, there isn't a difference. The only kicker comes in is right in this neighborhood here, is when you have the I squared, because of it being equal to -1, that allows you to go a couple more steps when you plug that in. But really not that big a deal. It allows a little bit more simplifying because of it, though. So, and again, if you notice, all these answers kept on being like a number plus something I squared. Well, that's called a complex number, and this is always going to be in this situation. This is called A plus BI, and that's how. And, a lot of times we want to put the variable up front, but with complex numbers, we put it in the back like this. So I think it's about time we actually talk about complex numbers and definitions and such. Okay, because we got imaginary numbers. Okay, so imaginary numbers is square root of -1. So I squared is -1. Kind of already done that. So let's look at the actual definition of complex numbers. And we notice that adding, subtracting, no big deal. Multiplying, just a little thing that added on. So they say a complex number is any number that can be written in the A plus BI format. Okay, A and B are real numbers, and I is the square root of -1. Okay, and then they said that A is the real part and B is the imaginary part. They like to split this stuff pretty thin here, right? Because they said A and B are real numbers, yes. And then we got the A is the real part and B is the imaginary part. Okay. And it just simply says the multiplier of the I, the coefficient. Okay. So let's look at this Venn diagram here, see if this can shed some light on it. Okay. So what we're seeing here is we got real numbers that's inside of the Venn diagram for complex numbers. We got imaginary numbers inside, but they don't overlap. Okay, they don't overlap any. So between real number and imaginary numbers, and they're inside complex numbers, that means all numbers are complex numbers. What? I don't think that 2 is a complex number. It's pretty simple. Just 2, right? 1, 2, 3, 4. Those are just simple numbers. That's what we learned before we ever got to kindergarten. We learned to count. That was very simple. They weren't complex. It's very simple. Well, that's not true. It turns out there's a secret life to all those simple numbers. Yes. So we're going to talk about the secret life to 17 in just a minute. Okay. So, but again, we have complex numbers, and you're saying that's 2 numbers. No, according to this definition, this is one thing, a complex number with 2 parts. Okay, so 3 being the real part, 4 being the imaginary part, 4i being an imaginary number. Okay, so when you have both parts, we consider that just a complex number. But what happens if you got a 0 I? Well, that means you only have the real part, right? And what happens if you don't have the 3? That means you only have the imaginary part. So the numbers inside here are both real numbers and complex numbers. The numbers in this circle are imaginary numbers, which inherently makes them complex numbers as well. But all numbers are complex numbers. So, and just to kind of prove that, I'm going to tell you about the secret life of 17. Now, there's certain things about, not just pick 17 because it's sitting right here, okay? Nothing extra special. So we got 17. What do you know about 17? Well, it's kind of, you could write that as like times 1, right? You could say that's divided by 1. That's kind of an assumed thing. You can say it has an exponent of 1. So those are all the secret life things about 17 that we just can't see, but they're definitely there. Okay, they're definitely there. So, but there's something else that we never knew existed till today. This 17 also has a 0i. Good grief. Okay, but we don't usually add things that have 0x, like 0x. All right, so we've been talking about this secret life of 17. So here's 17, and here are all the things that are around 17 that are assumed that we don't write. So but the point is, 17 is a real number, but it is also inside the complex numbers world, okay? Let's do a few examples and see if that helps just a little bit, okay? So let's first start off by this guy here, 9 plus 5i. That is a complex number, okay? It's got two pieces, okay? And it says that the 9, okay, and the imaginary part 5, okay? So the 9 is the what part? It's the real part, okay? 9 is the real part. And it's important that you use the word part because both 9 and 5 are real numbers, okay? But in this context, we're saying 9 is the real part. And then 5, it's not like it, I want to do it the other way. So 5, okay, that is the imaginary part. Okay, and again, you got to use the word part. Because if I just say real, that means 9 and 5 are both real numbers, okay? But 5i is an imaginary number, 9 is a real number, and then when you put it together, it's a complex number, 9 being the real part and 5 being the imaginary part. Kind of crazy. Yes, it is. I understand. What about negative 7i? Well, the real part of negative 7i is 0. That's the real part, okay? Because it doesn't there. There's no real part there. And then the imaginary part, right? The imaginary part, that is negative 7. I didn't write the I. You notice that? I did not write the I, okay? The number belongs to these sets. It belongs to the complex numbers and imaginary numbers. It's in both of those. Okay, so let's got a couple more here. Be good if you were able to pause the video and try this yourself and then see if your answers match what I'm going to put down. So now would be a good time to do that. Okay, well, hopefully you've got that done now. And so let's see here, 11. Well, we call 11, okay, we're going to call 11 the real part. Okay, and 0, the imaginary part. And then what do we say? This is going to be in the real and complex numbers. About this guy over here, right? Well, we're going to say that this is the real part. And then 1 is the imaginary part. Okay, and this is only a complex number. let's go back up to the beginning here. So complex numbers, what are the complex numbers and how do they add, subtract, and multiply? Okay, well, first of all, we figured out addition, subtraction is just like you would have an X. No big issue. Just watch your signs. That's always our biggest issue. Then we looked at multiplication with FOIL, and it's pretty much the same thing, except when you get an I squared. I squared, we discovered that when you take the square root, you square the square root, you get -1 here. So we took that out, plugged in -1. Caution to be careful because, again, signs is our number one error in algebra. So be careful through here. So that gives you +4, and then those two make 10. And the reason why we put the 10 in front, because this is an A plus BI format because it is a complex number. We said all numbers are actually complex numbers, but when we're used to dealing with these real numbers, the complex part is just plus 0i, okay? And then imaginary part, the real part would be just 0. Okay, so these real numbers are in both the real number section and complex. Imaginary numbers are in both. But these guys, these examples are only complex numbers because they're together, okay? And then we walk through these different little examples. Okay, complex numbers. Hope that is helpful.